So friends, we are still on motion in one plane. As I said in the last video, we have dealt with the problem of rain and a man. Okay, now here we are going to talk about something called river and boat. Now this may not be a boat exactly in this problem, but then this kind of problems, they are called river boat problems. Like river is flowing in one direction, then boat is moving in the water. It may move upstream or downstream. So that means the speed of river or the speed of stream, it is going to affect the speed of a swimmer. Number one, it can affect the direction of the swimmer, right? Let us see what exactly we have in this problem. A river 800-meter wide, it flows at 5 kilometers per hour. So that means speed of water, speed of river, it is 5 kilometers per hour. A swimmer who can swim at 10 kilometers per hour in still water wishes to cross the river straight. Now that still water is not given, but then when they say a swimmer who can swim at this speed, that means that is the speed in still water. Okay, he wants to cross that river straight. Now question number one, what should be his direction of swimming? Number two, what should be his resultant velocity? And number three, how much time would he take to cross the river or for reaching his destination? Now here we need to make a sketch. Okay, so if this is the river, okay, and this is the point where this swimmer is standing to start with. Let us call this point A. Okay, now the thing is, he has to reach straight on the opposite bank, correct? So he want to reach point B here, correct? What is the speed of river? Speed of river, it is 5 kilometer per hour. Okay. Now okay, he can swim at 10 kilometer per hour, but then suppose from A to B he wants to go, and if he swims in this direction, okay, if he swims from A to B, because of the river current, will he not be pushed in this direction? So he would reach somewhere here, correct? But then where does he want to go? He wants to go from A to B, straight opposite to the opposite to where he is standing, isn't it? So what should he do? In which direction should he swim? So logically here, you can simply make out that he should take this this direction. So which exactly how much exactly how many degrees, that we don't know, but then we can find that out. So now this is where he swims. Let us say from here to here. So he starts from point A. Okay, starts swimming towards point C here. Okay, in this direction, correct? But then my river current is in this direction, right? So A to C, and river current is from C to B, and then he finally reaches there. Okay, so my vector triangle would be like this: AC bar plus CB bar is equal to AB bar, correct? So if I would say velocity of swimmer, okay, velocity of swimmer in still water, that is equal to 10 kilometer per hour, and velocity of river is equal to 5 kilometer per hour, correct? Then so this is my Vs, this is my Vr, and this is my V, correct? So that is the relative velocity or the resultant velocity. So resultant velocity would be this. Okay, so now let us try to find out how much this is. Now here, if you see, he is going straight on the opposite bank, correct? So this AB is perpendicular to the river, the line of flow of river, correct? So obviously this is 90 degree. We can use parallelogram law of vector addition, or maybe here triangle law, but then or even you can make use of sine rule and cosine rule over here, but then using Pythagoras would be the simplest thing to do, correct? So my V, I would say V square is equal to Vs square minus Vr square, and therefore your V is going to be root over, what is your Vs? Is it not 100? Vs square minus 25. Okay, so that much root of 75. So that would be how much? 25 into 3 is 75. So 5 root 3, and that would be equal to, now you know that it is root 3 is 1.732, and that multiplied by 5, so it is going to be equal to 8.66 approximately kilometer per hour. Okay, so even though he is capable of swimming at 10 kilometers per hour, okay, because of river current, his effective speed is going to be 8.66 kilometer per hour. Okay, so what should be the direction of swimming? What would be his resultant velocity? So first of all, we have answered part 2 of this question. Okay, what about part 1? Now for part 1, the direction, I want this angle theta, correct? So now I have opposite side and I have the hypotenuse. So I would say sine theta is equal to, opposite is Vr upon Vs, and that is equal to 5 upon 10, that is equal to half, and now sine theta is half, so theta is equal to 30 degree. Okay, that means theta is equal to 30 degree. So he has to swim at 30 degree with the line joining his point of starting and the point where he wants to reach, correct? So that theta you have got. What about the third point? Now here how much time will he take? Now for this you need the distance, and they have already stated right in the beginning that width of the river is 800 meter, correct? So my time is equal to, it is distance upon speed, now here I'll be taking the effective speed which we calculated here. Now that speed is in kilometer per hour, which we need to convert into meter per second. Okay, so either you convert that speed into meter per second, or then you take this distance in kilometer and you get your answer in hours. Okay, but then let us do simple things. Okay, so my distance is 800 divided by speed is 8.66. So for converting into meter per second, what do? I convert, I multiply by 5 upon 18. So my 5 will come here and 18 will come here. Okay, now this calculation you can very easily do on your calculator and write your answer. So now to summarize, for addressing this kind of problems where you haven't given the width of the river, the speed of the water current, and then speed of the swimmer in still water, okay, what you need to do is you just need to apply your logic, right? Make the vector triangle and find the answer. It's quite simple, isn't it? Thank you so much.